Welcome back, guys. So in the previous lecture, we implemented parser and started handling some expressions. Right, we can handle numbers, strings, and also printf function call. In today's lecture, we'll talk about symbols, that is variables, Boolean literals, and others. And let's start actually from the true and false values, right, Boolean literals. And in LLVM, Boolean is represented as 1-bit values, that is get int 1, which accepts also true or false, specifying what should be the value. Right, true is 1, false is 0. Okay, sounds good. We can test now Booleans. Okay, let's try symbol itself. And as you can see, nothing happens. We don't see any output. Right, the return value is 0 from our generic handling. And this is the first time we meet some optimizations done by the LLVM. Right, in this case, since true symbol is not used, it's just eliminated. Now, to see the actual value, we need to print it. So let's use our printf function. And we should see printed 1. There we go. Let's add new lines to see it clear. And yes, true is 1. Let's test false. And false is 0. So everything is correct. And as you can see, the actual value which is printed is exactly the false value. That is LLVM IR understands true and false constants as well, which again 1-bit size, that is type I1. And in general, we should be able to access any symbols, right, any variables. And the first type of variables we consider are the global variables, right, even pre-installed. So let's start handle the variables. And let's start from the helper function to create global variables. We accept two things, the variable name and its initializer, that is initial value, which, take a look, should be a constant. We cannot assign just expression. This is specifics of LLVM. And module has the API called get or insert global, passing the name and passing the type of the initializer. Now, once the variable exists, we can get it, right, by get name global. We also say that this is not a constant, right? We'll be able to write new values to such variables. And we also specify the initializer. Okay, finally return the variable, and this function should be enough to start creating the variables. To create variables, we'll be using var expression, right, similar as we did in previous classes. And as you can see, the value might be in general not just a constant, right? So I'm leaving to do for generic values for the next lectures, and today we'll just use just initializer. So we call gen the initializer and then call our method create global variable. Okay, so that should be it. Let's test our var expression works. Right, let's define the variable version. And nope, some typo. We have to use list here. Try again. All right, one more error. Yes, as we said, the initializer should exactly be the constant. So our gen function returns generic LLVM value, which might be constant, might not be constant. So we have to explicitly cast it. All right, try again, and it works. As you can see, we defined a global variable, which is called version, which has the value 42, right, initializer, and the alignment is set to 4 bytes. And LLVM has multiple types of variables, 3 of which are the main types. So today we discuss the global variables, right? Such variables are located outside of any function, pretty much part of the binary. Once loaded at runtime, they can be mutable, but the initializer should be simple value. And here we see the example. Again, the global variables are prefixed with the ampersand. Now, the second type of variables are the local variables, which we'll discuss in the next lectures. And here we have the two types. Now, first of all, the register variables, which mainly used as temporary results of some operations. Right, for example, here we see the addition operation, which stores the variable number 1, right, automatically named. And also we can specify the name of the variable. In this case, the variable x is also local and also the register variable. Now, the register variables do not require stack allocation, right, explicit stack allocation, as we'll see later. And the variable names are subject to the static single assignment, right, this special concept used in compilers, which states that each variable can be assigned only once. As we'll see later, it's used in many optimizations, so LLVM leverages the SSA form. And the second type of the variables are the stack variables, right, which are also local variables. Similar to the register variables, we use the ampersand sign. And here we see the alloc a instruction, which is used for stack allocation. And also we should use store instruction to store a variable, right? Once we have the variable, we can use this address to store a new value. Again, the stack variables are also SSA. And in general, the static single assignment is the property of the variable name, right? Not of the variable itself. Which means we can mutate the value stored at the address of this variable, but cannot reassign this variable, right? We need to use it again, we need to load it and use a new variable name. But again, the local variables will reach in the next lectures. Today we'll talk mainly about the global variables. And also we can pre-install the global variables, right? Let's do this right away. In our compile function, we can just create the global variable, the same name version, with the value 42. And now we can implement the access to the global variables. Again, today we handle only the globals, and later we'll handle it generically. To get the value, we use just getNameGlobal, right? Exactly the same, passing the variable name. Sounds good, let's test. And we see some weird value, which is definitely not 42. In this case, this is the address of the variable itself. Now, to get the actual value of the global value, we can just use getInitializer, right? Since this is the constant. But of course, this is not generic value, right? Since we can override eventually the value of the global variable. So we will change it in the future lectures. But for now, that should be good enough. So let's test again. And it works. As you can see, version is now 42. And for now, we can also call getInitializer from the variable declaration. So we can inline variable usage. Okay, let's try it. And it works. Okay, sounds good. We now have global variables. And in the next lecture, we'll start talking about blocks. And that is the begin expression and about local variables. Right in this example, inside the block, the variable version should have the type string. But once the block is finished, it again should be the global variable, that is integer 42. That's it for today. Thanks and see you in the class.